Well, we're finishing up our little counter shaft. I needed the hub for it, so we turned one of those. I didn't bother to film that because it's just a standard turning. But what I ended up and did, this counter shaft was, this is the arm that came off of the horizontal counter shaft assembly that I had. So it was fine, but it was a little bit chowdered up. Somebody replaced the end on it at some time. We've got a couple of holes in there, off-centered where they drilled them crooked basically. And looks like they've, I don't know, peened in there. I don't know exactly what the deal was, but anyway, it's basically two holes that are drilled in. So what I ended up and did is I took a piece of stainless. This is just a piece of scrap 1-inch stainless. And I've seen these hubs made a couple of different ways. I've seen pictures of them where they've got a shoulder out on the outer edge out here, and this, well, it's the inner edge. It sits up against the counter shaft brackets. But that's, when I looked at my little Atlas mill, it's just got a straight piece on it, about 1.25 inches long, which is what I built this one. That looked like good dimensions. So what I did is I set it up in the middle. I went ahead and turned it down, just turned the outside. This was just some scrap 1-inch I had, so it's just under 1-inch diameter. Centered, found the center of it, and I started out with a longer piece of stock, so I had something to hold on to. Turned that off, set it up in the milling machine vise, and I drilled it for the through pin, which was these holes, just a standard roll pin that went through. And then I went back and aligned it as best I could with the bar here, and got them together and got alignment. And then I drilled those undersized initially, then went back and just final drilled them to size for a roll pin. And that just knocks right in there. I've not reassembled this for final assembly until now, so hopefully I don't look too stupid doing it. Don't have something go terribly wrong. I took a 1-inch roll pin and just shortened it up slightly so it didn't stand proud. Once I got it to that point, why then I went ahead, set it back into the counter shaft assembly up on the lathe itself, and figured out where it was at rest so that I knew where I wanted the handle to go in, and then where it would be when it was engaged to put tension on the belt. So, and the main clearance issue was to make sure it was at enough of an angle so that when the tension was released on it, why this didn't interfere with any of the brackets that were on top. So then I set it back up in the mill. I still had my 0 there. So set it back up in the mill and drilled and tapped it for, this is a 5/16 20 thread. And then took it back, took it back to the lathe, faced off the end, the extra material that I had, and polished it up a little bit. And there's the complete assembly. So we'll go back, stick it over in the lathe, and give you a picture of that. But now the counter shaft assembly is pretty well completed, other than to install the belts. So here's our completed assembly. Cotter pin goes in this end to retain it. I'm not going to install that quite yet. I'm going to replace that with a new cotter pin. But this will set right in there like that. There's with no tension on the belt. And then it rotates to that position to tension the belt. And it's good to go. So other than final alignment, this the counter shaft setup is ready to go. Well, I've got belts to go back on here, and we'll get onto that in a minute. We're going to start disassembling this. But quick little check, this is not going to be real accurate or real scientific. The headstock is basically the way that I purchased this headstock, which it's a Babbitt bearing headstock. It had the spindle in it, and everything is as it was. I disassembled it to powder coat it and everything, but I didn't change anything in the bearings. I put the same shim pack back down in, and it's a little bit stiff. We'll see once it's oiled up and I run it a little bit how much it is. I think we've got minimal end shake, although we can still adjust that down the road if we need to. But a quick little dirty test I'm going to run is I want to know how much, or just an indication of how much play we've got vertically, especially in this spindle. So what I've done is just taken a block, because my little Noga indicator won't go tall enough. And I don't know if we're going to be able to see this on the video or not. But what we're just going to do is set it up. This is not accurate. Guys will say, oh, you need an X amount length bar to fit in the spindle to, basically we're prying on the spindle. And we're going to set that just about there. And this is not real secure anyway, but it'll give us a little bit of an indication, kind of a baseline. We're pretty much centered up there on the vertically. So what I'm going to do, and zero it, see if I can do it around the camera so we've got some indication. And I have nothing to really compare this against. All we're doing is using this as a baseline for adjustments we make down the road. So, and this is what I had available that wasn't real, wouldn't mar up the inside of the spindle, and I just grabbed it. So vertically, we're getting virtually no movement at all in that. And granted, if I put a longer bar in there and pried on it, I could get some deflection. But that needle is barely moving, and it doesn't show up very well on the camera. You're going to have to take my word for it. But we're getting virtually no deflection on there. So vertically, we're pretty good with that, with the way that's set up. I wonder what we can do side to side. I actually expected to see a fair amount of movement in this spindle, just because I felt it was probably worn enough that we were probably going to get quite a bit of deflection. Let's see if we can get on the side of it here. Now, this is not gonna go where it's going to show up either, but get a little bit of an indication of what we've got movement wise. And there again, you're going to get guys that are going to say, oh, you need to have this much deflection, or you've got too much run out, or whatever the case may be. And I think it's all relative to what your expectations are, precision-wise and accuracy-wise. Now see there, I've got not quite one tick mark of movement. So now we can basically, we're going to disassemble this spindle and the counter shaft. We're going to pull the counter shaft out. We're going to go ahead and install our belts. Let's go ahead and pull this counter shaft back out. Raise this up a little bit so you've got a little bit better view. Hopefully this angle will give at least some idea of what we're doing here. This is basically the procedure you would use to change out the spindle belt. So we'll pull our counter shaft assembly out, set it aside. This was our nifty little handle for our adjustments. Let's raise that up and get it out of the way. And of course, if you're changing these out, well, you would have went ahead and pulled the outer belt off already. So there we are, disengaged. Loosen our bearing caps. And with that small amount of run out, we'll have to watch when we put these caps back on, run it a little bit, make sure we don't have them too tight and overheat our bearings and spindles. You'll be able to tell because it will warm up. And of course there's going to be shims underneath each of these caps, front and rear. And they're how you adjust your preload up to a certain point, while you'll use those shim packs to adjust your clearances. Since these were off, they should come off relatively easily. We shouldn't have any issues. Okay, this front does not have any shims under it. And you want to be sure and reinstall your bearing caps and your shims back in the proper position that they were in to start with. This one's a little bit tighter here. Okay, and there's our other end. This one has several little hand-cut U-shaped shims in them. You know, make sure they go back in the same orientation as they were before, assuming whoever set it up before did it properly. And there's our shim packs out. So now our spindle's ready to lift out. So for belts, I source my belts locally. I don't bother to order them because on stuff like this, there is some references as to what belts go on there. I did not find a reference for belts for the vertical countershaft. So what I did is I took the link belt that I had and I just fished it around through our pulleys and measured it to where I thought the proper length was, which then I just marked them. Marked that one like that, the end of one and the little black dot on the other one with just a Sharpie. And that gave me the main spindle belt. And then for the outer countershaft belt, it wasn't long enough with this link belt. I just hooked a piece of wire to one end, just scrap wire that I had, taped it up, linked it so I could hook them together, and that was the length for my other belt. And that's the way I measured them. Hauled my little link belt up to my local Ace hardware store and matched up what I thought I wanted. So for the motor belt, I came up with a 4L300, which hopefully will be the right belt. So we'll just take our little belt, we'll slide it on there, and we'll set this back in. And we'll wipe these out. And we'll of course flood these with oil again when we reassemble them. We want them to be pretty clean. And before we put those caps on, let's go ahead and slide our countershaft assembly back in and see how close we are to the proper length. Or if we're even close. All the way down there. Whoop, 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 whoop. Okay, I think that one's going to be pretty close. We might have gotten that one right. Let's go ahead and reinstall our caps. With our shim packs. Now it'll be interesting to see once we start the final alignment and measurement of this to set up this. With the way these shims are installed here, why, depending on how it was last time it was babbited, if it was ever babbited since the factory, is if this if the spindle points downward, or if we're going to have issues there, because we've got shims in the back bearing, or in the outer bearing, and no shims at all in the front. So it at some point was probably used to compensate for something along the way. We'll have to see how that works out. If you find these videos helpful, why go ahead and hit that subscribe button. If you hit the bell notification, you'll know when I put out a new video. And any comments or suggestions, leave them in the comments section for me below. Let me know what you think of this. And thanks for taking the time to watch.